Hello, in this video I want to solve problem 1.8 from chapter 11. We are given an inverse demand function, P equals 13 minus Q, and we have the monopolist cost function, CQ equals 25 plus Q plus 0.5 times Q to the squared. Okay, so the question is, what is the profit maximizing quantity, price, profit, and should this monopolist shut down or should it continue to produce? All right, so I'm just going to go ahead and solve that. The first step we need to do is, of course, find the marginal revenue and the marginal cost curves, because we know that the profit maximizing quantity will come from setting marginal revenue equals marginal cost. Revenue is a function of quantity, which is equal to P times Q. So that would be 13 minus Q times Q, 13 minus Q squared. And therefore, the marginal revenue, and we knew this already because whenever we have a linear demand function, marginal revenue is equal to same intercept twice the slope. All right, so we got 13 minus 2Q is the marginal revenue. We'll take the derivative of the cost function to get marginal cost. That's equal to 1 plus Q. Setting them equal to each other to find the optimal quantity gives us 12 equals 3Q, Q equals 4. Plugging the quantity into the demand function to find the maximum price that the monopolist can charge, 13 minus 4 is equal to 9. And therefore, we can calculate the profit, which is 9, price times quantity, minus the total cost, 25 plus 4 plus 0.54 squared. So that's equal to 36 minus 25 minus 4 minus 16 minus 8, which is equal to well, let me calculate that. So 36 minus 25 minus 4 minus 8 is equal to minus 1. The question now is, should this monopoly shut down or should it keep producing? Well, the answer to that question is the same for the monopoly as it is for a competitive firm. Namely, you should shut down if price is less than average variable cost. All right, we know what the price is. It's equal to 9. And the question is that less than average variable cost? Well, here's our cost function, and the part that depends on quantity is our variable cost, and therefore our variable cost is Q plus 0.5 Q squared, which makes the average variable cost equal to 1 plus 0.5 Q. And since Q is 4, we have that the average variable cost is 3. So clearly here we see that 9 is not less than 3, and therefore the monopolist should not shut down. It should keep producing in the short run. All right, I just want to do one more thing, which is just draw the diagram so we can see how everything works out in a diagram as well. So I'm going to draw my demand curve. So 10, 11, 12, here's 13. So we have a straight line demand curve like this. We have a marginal revenue curve which is the same intercept twice the slope. So that's the marginal revenue. You can see that one will go through 6.5 because this one goes through 13. And then we have a marginal cost curve that starts at 1 and then has a slope of 1. So draw this one. Oops, not very straight, but here's the marginal cost curve. It's going to look something like this. All right, if I have these ones, I can find the profit maximizing quantity by setting more revenue equals marginal cost. So that's going to give us our 4. I'm going to go straight up here to find the profit maximizing price. So that's our 9. And if I wanted to shade in the profit, I would have to actually find the average cost. Now, average cost is, of course, equal to the total cost divided by quantity. So that's be 25 divided by Q plus 1 plus 0.5 Q. If I plug in the profit maximizing output level, you'll see that I'm going to get, well, so that's 25 divided by 4. It's pretty easy, but so that's 6.25 plus 1 plus 2, 9.25. So basically what we're saying here at the average cost will be equal to 9.25 there. So if the average cost curve had its normal shape, average cost is going to look something like this. And if I had to shade in my profit, it will be negative because the average cost is greater than my price. So this will be the negative average. Well, it's going to be negative profit because the average cost is 9.25, which is greater than the price of 9. All right, so yeah, that takes care of this problem. Thank you.